Okay, here's the 4 main steps to balancing reactions. First thing you do is you make sure that all the formulas are correct. If you don't do this, the equation won't balance. Then you'll draw a line under the yield sign. We'll use the 2 spaces under the products and the reactant side to count the number of elements on each side. And then we'll use coefficients to balance the reaction. We're going to balance oxygen last. Let's balance one together. So here we have the reaction between sodium and chlorine gas to form sodium chloride. I've already done step 1. Step 2 is to draw a line down underneath the yield sign. And then moving on from that, step 3 is to count the number of each element on both sides of the reaction. So we've got the products over here and the reactants over here. So we've got sodium here, chlorine here, and then sodium and chlorine there. Make sure you write them in the same order on both sides of the reaction. So let's count them up. We got 1 sodium atom on this side and 2 chlorine atoms on this side, 1 sodium atom here and 1 chlorine atom here. You can see that they are not balanced. So then we have to go to step 4 and use the coefficients to balance reactions. Now coefficients are nothing other than just numbers that go here. So in this, once you've got the formulas correct, you can only change the coefficients in front of each element or compound. So for this case, I need 1 chlorine over here. So I'll just multiply this by 2. So then that changes this to 2 sodium atoms, and this also changes that to 2 chlorine atoms. Then I can come back over here and see that the sodium is no longer balanced. So all I have to do is just put a 2 there, changes that to a 2, and now we're balanced. Okay, let's try another practice problem. So here we have the combustion of methane. I've already done step 1, which I wrote all out. You can check it and make sure they're correct. They are. So then the next step is to draw a line under the yield sign, separating the products from the reactants. Then we need to count how many atoms we have of each element on each side of the equation. So we've got only 3 elements in this equation. We've got carbon, hydrogen, and oxygen. We can write that the same way on both sides. And then we count up how many we have. So on this side, we've got 1 carbon, 4 hydrogens, and 2 oxygens. On this side, we still have 1 carbon, then there's 2 hydrogens and 3 oxygens. If I have the same element in 2 different compounds, I just add both of them. So this is 2 plus 1, so that gives me 3. Then we need to start balancing the equation. We're gonna leave oxygen for last. Carbon's already balanced, so let's balance the hydrogens. So to balance the hydrogens, I needed 2 more here. So I can just put a 2 there, which changes that to a 4. But it also changes the number of oxygens I have. If I have a number here, it's going to carry its way through. So that means 2 times 1 is 2, plus the 2 over here means there are 4 oxygen atoms total. So then I can go to the reactant side of the equation and realize that, oh, if I just put a 2 there, that goes to a 4, and now we're balanced. Let's try a third practice problem. So you see, with this one, we have a compound with parentheses around it. So that doesn't really change much, but it does change it a little bit. So let's jump right in. Let's go draw a line. That's step 2. Step 3, we need to count them out. So we've got nickel, chlorine, and oxygen. Do the same order on both sides. We have 1 nickel on this side, and then this is where the parentheses come in. So you see, if you have a parentheses, it's just like in math, you have to distribute it in. So that means I have 2 chlorines on this side and then 6 oxygens. This side is the same as the other 2. We've got 1 and then 2 there and 2 there. So you see, we're not balanced, so we need to go and we need to balance the equation. Again, balance oxygens. Normally we balance the oxygens last, but really it's kind of easy on this part. So here you've got 6, everything else is balanced, and really all you need to do is put a 3 there, changes this to a 6, and then we're balanced. All right, for our last problem, I want to show you one last thing that you need to do, and mostly this is for combustion reactions. This is the reason why we balance oxygen last. Okay, so let's jump in with this one. So we've got this. You draw a line down the middle below the yield sign for step 2. Then we put out all of our elements. Again, it's a combustion reaction, so we only have 3. So it's just carbon, hydrogen, and oxygen. Put the same order on both sides. We've got 3 carbons on this side. We've got 8 oxygens. You got to remember this one. And we have 3 oxygens on this side. On the other side, we've got 1 carbon, 2 hydrogens, and 3 oxygens. That's great. That's awesome. But this is kind of when it starts to get crazy. So first thing we should do is either balance the carbons or the hydrogens. It really doesn't matter. Let's go with the carbons first. So that means I need to put 3 here, changes that to a 3, but it also changes the oxygen to a 7, because this is 3 times 2, which is 6, plus 1 is 7. Then I need to balance the hydrogens. So this, all I need to do is just put a 4 there, changes that to an 8, then changes the oxygens yet again. Again, why you balance oxygen last. So that's 6 plus 4, which is 10. Now, the crazy thing over here is that you see you've got an oxygen by itself on this side. I could divide 10 by 2 and put a 5 here, but then I'd have 11. And if I put a 4 there, I'd have 9, so it can't balance out. So with this, you have to multiply the coefficients of all of them by 2. For example, this is a 1 here, so I need to change that to a 2. This I would leave blank for now because we're going to change it later. This 3 goes to a 6, and this 4 goes to an 8. So then all of these things will inherently double. So that's 16, this is 20. Then we've got 2 oxygens there and 4 oxygens there. So 4 for now. This is also 16, and that would be 6. So this is kind of where it's easier to balance it all. You've got 2 over here. So you subtract 20 by 2, and that gives you 18. 18 needs to go here. So then what times 2 gives you 18? That would be 9. So then that would be 20 overall. And now we're balanced.